Hello, good afternoon. I don't know that anyone's here yet, but hope you're having a good Sunday. It's been a couple weeks. Last week was a little bit too busy of a weekend for me, so um, it's doing some things with my wife and with family. So we decided, yeah, it's probably not a good day to stream. But here I'm back. What I'm thinking we'll do today is we'll do some Rust. We may do some Tree-Sitter. Continue on the NIF stuff. Um, but I might want to put that aside for a little while. So I'm considering. Been following this tutorial guide with it's on available on YouTube. I'll pull that up so we can show it in a minute. Um, but the it's a nice tutorial about how to use the latest release of Bevy. And Bevy, if you aren't familiar, is a game engine in Rust. Um, has a really powerful uh, entity component system. And when I say entity component system, system is a thing. Part of this, it's a system. Yeah. Anyway, library. It's an entity component system library. And the entire it's a data driven game engine essentially, and the entire game engine is built around that, and it's really neat. I've been wanting to do some stuff with it for a while, and of course I've seen a lot of the stuff that you know my former coworker Chris Biscardi has done. This tutorial though I think is really good about going from the basics um, up to something that's kind of working without getting too complicated. So I also saw the topic. I didn't participate, didn't have the time or the knowledge. I don't think. Um, I did see the topic of the latest Bevy game jam, which is called "That's a Lot of Entities." So I think they were trying to go for let's see games that have a lot of game entities in them. So we might get inspired by that. I'm hoping we can get to some Bevy today because I think it's a really neat framework, and they really lean on the Rust type system to do some pretty remarkable things. Um, and it's growing. Like it's a really interesting space. So hopefully we'll get to that. And I will. We'll start here by looking at um, a few things that are a little bit less interesting, possibly at first. But we could do a little cleanup on Tree-Sitter. I don't think it'll take very long. I need to push a release of Hardhat, so we can do that. That'll just take 5 or 10 minutes. And yeah, so why don't we get started? If you join the chat, please say hi. Hello, I recognize some of you. Welcome. All right. Okay, so this is the tutorial that I was talking about, Zymartu games. It's pretty interesting. I definitely recommend you go into it. They're not very long, and he includes all of the code. Hi, Isaac. Good to see you. He includes all the code of every video in the same repository, so you can see the changes. And I'll show you. I worked through this tutorial. Obviously, you can see I've watched all 4 videos. I worked through this tutorial and typed in the code myself, and it works. We can show that off. But let's go over here. So I wanted to get some maintenance done on Hardhat. We're going to bump the version real quick. And the reason we want to bump the version is that there were some changes made in the last couple of weeks since we did the release, the 1.0 release. Basically, same day, a viewer sent me some improvements. So we'll figure out a way to get their contribution credited Maybe we'll start a change log. That would be pretty good to have in there. They're mostly like cleanup stuff. This one is really good actually. That we're not raising a a runtime error. We're raising compile error, which gives a lot more information about where that call had. So has a file line as part of that error. That's pretty good. There's some minor like syntactical things. I didn't really want to fight about this. They prefer and or, and I prefer the short circuiting versions, but it's not a big deal. Yeah, and this one is like, bind and then do the URL safe encoding. And here's another one where it was just kind of a stylistic thing. This is actually much better than this repass error thing that we copy pasted from Tesla's version. So the try catch also can have an else block, which is where, hey, this doesn't fail, but actually returns a value, doesn't raise an exception there. And so that's just taking this function and inlining it in the else block, which is pretty nice. And here, I don't actually know that this is a big deal, but again, the other improvements are good enough that I felt like this has a bit more clarity. So not this like single line check. So we have an else. Anyway, this was a nice contribution. Little stylistic improvements. And can we go back? Okay. And then we bumped regulator up a version. So I think this is worth a tiny release. This doesn't actually change any functionality, but here, let's make a change log. And we're going to say v1.0.1. And let's put 1.0.0 initial release. Okay. And we need to probably take the description from here, from this pull request. I don't know that I'll make a more descriptive, but we'll use that number in the change log so that it hopefully gets auto linked. And this person has a very interesting username. Let's see if I can copy it there. And do people usually do this in reverse order or chronological order? I don't know. Let's go back to the change log. No, okay. My browser history is all messed up. Okay, so bump regulator from 0.5 to 0.6. .5.0 to 0.6.0 by dependabot. And this was 13. Okay. Let's do a little. So we're going to tag this eventually, of course. But let's go ahead and bump the version number. And I think that for the docs, where's our docs? Let's really quick look at xdoc. I want to see how we can add the changelog. So extras is probably what we'll do. Yeah, let's do that. Extras will be changelog.md. And we need to put a h1 title in here. That way we'll get the documentation to include the changelog as well. So let's real quick docs. Okay. Next docs. Always typos. Okay. Let's see that that looks correct. Yeah, so we're getting the change log. It might make sense for us to put links here. I think that's worth the extra time. Maybe in the future, we can do some things like use a tool that auto links this stuff. But for now, let's just put in the links. Five S's in their username. Cool. Okay. And then we'll copy this. That's 13. And let's put that in there. I don't know that there's actually depend-bot. Let's look that up real quick. Depend-bot. Yeah, it actually has an account. Okay. Easy enough. Easy enough. Okay. So let's run the docs again and see about what did I do before? Open. There we go. Okay. Change log. Okay, so now we're getting actual links to those pages, which is good. And since that is working, let's go ahead and make a commit. And we will, I think I just said release 1.0. Let's do something similar. Release 1.0.1. And we will get tag. Let's see what, yeah, so we had V in there. Yeah, that makes sense. 1.0.1. And let's push main and tags. Okay, so you know what will happen here. So we got this, our actions, you know, it's going to run the release as well as CI. And I didn't really change that much, so I think it's probably going to be fine. Yeah, so it's compiling. And then it'll run the release, generate the docs. Cool. Okay, so a little bit of maintenance done there. And I think we're good to move on. So, you know, I usually have this up in Emacs. I may have shown it earlier. Let's close this out. We're going to look at Tree-Sitter. Hopefully we can do, sorry for the flashing. Hopefully we can do this this task, this cleanup task, pretty quickly. So let's open recent Tree-Sitter. Okay, so the essence of this is we are doing a bunch of goop that we don't need to do. Really what we should be doing is we are going to use the this error crate. So let's look at this error. This is a great crate. And basically it it provides a derive, so you can create this enum, which is the different type of errors that your application will create. So errors not in the sense of exceptions. They're not exceptions like an Elixir, but they are types that you would return usually as the right-hand side type of a result. So and the big things here is it can be derived from a different type of error. So this will, when I say derived, that's not in the sense of this derive macro, but it will be automatically converted. And this is kind of what we want to do, because what we can do in our NIF functions, rather than having this, with NIF result, which is really pretty confusing, this into NIF error, with NIF error, is just trying to get around the orphan rule. But what we can do instead, so we can do something like this, but make it a bit more direct. So let's see about doing that. Let's define our own error type. And then we should be able to dump a lot of this code. And we're going to, let's add, let's see, what version is this? We can go to source and see what version it is. No. Let's look at the, oops. Come on. Let's look at this error. 1.0.5. Okay, so maybe we'll just say this error 1.0, and that will be sufficient. And then we're going to derive error, probably debug, use this error star. And let's look into, what are the sorts of errors that we support. So let's say term, maybe, or we'll say atom. So this is going to be let's look at the documentation for this macro. I'm not sure, you may have to provide the format string. Okay, so a display impl is generated if you provide. I don't think that we're going to bother with that, because I think that we'll make a special case for this atom one, because what we're really concerned with here is the term coming out right as we're returning from the NIF. And it's basically on all these others we're just doing format. So we could, yeah. Okay. So we're not going to do that. Let's do this attribute will tell it that you can basically use the question mark operator. What it'll do is it'll implement the from trait for this type into our type. And we're going to do something here similar. Query error from. The challenge might be this. We may have to, because of the type there, the generic. Anyway, let's get these in there first. I do want to get to I do want to get to Bevy, so if this is going to take too long, we will just stop. Um, the problem with this generic is that I don't want to make this enum generic. Because then we will have to well, let's start with that, I think. Um, because I don't know all the cases where this is going to be a problem. But let's go ahead and put that in there. From and then we'll make t here. And I'm not going to specify what t is. We don't actually care. So right. So what we'll be able to do is get rid of these implementations. And then hopefully just use the question mark. Okay, so what we want to do is we're going to say impl t because we have this generic in here. And actually, let's do our 0 just on all these. This will generate the display. And I'm going to go ahead and do this one, but we're going to make this special case for this, right? We're going to say from error t for rustler error, right? And we're going to see error t self. Okay, and then we're going to match on E. We could also do if let, maybe. Let's just match on E for now, because this generated the display trait for this variant. But the only thing we want to do is special case this atom variant. So we're basically turning this impl into NIF error into a match up here. We say error atom of A. We want to do this. And let's name that a useful variable. Let's name that as well. And that's going to be atom. So here we are making a special case for this particular thing, and then for the rest of them we're just going to do this, which is what we were doing before. And then what we can do is basically delete all of this stuff. Yep. So let's delete code. That feels good. Oops, I didn't mean to delete the from. So we can, and now we can go in here and search for all the places where we call with NIF error or into NIF error. With NIF error, and remove them. Basically, what we should be able to do is just replace it with the question mark, which is much better. We might need to have the map error here. Actually, it's, yeah. Okay. Let's see here. Right. So we should be able to remove this with NIF error here as well. Of course, we're going to have to make sure that like any of this stuff comes out as the right types. If we have to introduce another question mark here, we could, it's not that big of a deal. We could say something like, this might actually be clearer code, question mark. Oops. Right. And then and then we would return resource arc new parser. That's a little bit clearer code. Right. Okay. And then the other thing is, in our other files, we're gonna have to make sure that those return the crates error type. So let's see. Make sure we're not using any of those with NIF errors. Let's go there. Right. And we're not going to do with NIF error there. We might need to generate a delegate method on this lock so that it returns our error type. That will probably be a problem. All right, but that should be a lot cleaner. Okay, so we've got that. Let's run this again, see if there's any other place. Okay, so here, yeah, I could also use map. The problem is the type. So I think you're talking about, for example, up here, this where I've added the let parser. The problem is that if this returns our error type, you have to have the question mark, which implicitly injects an into on the contained error type. So if you don't do this, then you have to do that map error dance as well as the map. And we were doing map before, right? But we would still have to convert the type manually if we're just going to return that expression. Yeah, it's fine. It's not a big deal. Honestly, more bindings is not a bad thing. My tendency is to go toward the functional style in a lot of cases. But yeah, there's not excuse me, there's not a reason to do that here. So we're gonna this is another case where we're gonna have to do this, right? We're gonna remove the with NIF error, and let's make a function. We'll make it public for right now. It doesn't matter. It's not going outside. This is self, and this is going to return. What is self.0.lock return? That's going to return a mutex guard. Let's actually just copy the signature mutex of lock. Lock result. Okay. So lock result is result of guard or poison error guard. Let's copy this, and then maybe we can back our way into it. Okay, so this is a result of guard. Oops. And guard is a generic. So let's go back to the previous one. Over mutex guard. So this is standard sync mutex guard. It has a lifetime and the contained type, right? This is going to be did we import standard sync? Let's import mutex guard as well. That'll make this a little bit easier. Mutex guard of the anonymous lifetime, and yeah, this type signature is going to get a little messy. We could. The thing is, what we want this to return is our error, right? Create error. And except that we have already imported that. So that way, when we call lock anywhere from outside or inside this thing, we are returning our own error, right? So we could say self.lock.0.lock guard is that question mark. Okay, guard. And then we are converting the poison error that might happen with locking. This is going to be Tree-Sitter parser, right? So that's our contained type right there. And then we'll do something similar for tree. Like, it's not a big deal. Okay, so this question mark turns it into our error type, and then we are always going to be able to return our error type from this. So okay. Sometimes I would like to use something sum instead of sum a value, but yeah, I've occasionally run into that. Okay, so we're going to do, let's remove this NIF error, and we're not going to call it on 0, we're going to call it on self. And we've already, made a from for that, so we can remove that. That's looking a little better. Okay. This type signature is not great, but what we can do for tree. And I'm not sure that we want this deref. We might need to see where we're using that. I think I just did that by reflex because we don't do it for parser, right? And it might not be good to expose the fact that this is a mutex inside, just from the point of view of, and I think actually I probably just did it to get this lock, right? And this is tree. Okay. We have some panics in here that I'm not real comfortable with, but it's okay. Yeah, let's remove this deref. Doesn't Elixir do that with the pipe? Seems useful. Does Elixir do what with the pipe? Okay, right. So so we're gonna have some compiler errors here in a second. Let's make sure there's no more of these with NIF errors. Here's some in query. Let's go over there. Okay, so this is not going to return NIF result. This is going to return result of our error. And we'll get rid of the with NIF error here. All over the place. Man, I made a mess in the past. Oh, yeah. A value piped to option sum. Yeah. I mean, in the sense that that variant for option is the name of it is a function that constructs the value. Yes. Piping is great there in that case. That's so Isaac was asking, piping into a constructor of a type. Yeah, I mean the semantics are different enough from Elixir that sort of thing is not going to be possible. But let's make sure that there's no more. Yeah, so here, let's run this again. Okay, and we have excised all the with NIF errors. Now I know, or I'm fairly certain that this is not going to compile, but we should try it and see what happens. Yeah, okay. So, and some of it is probably that we have something in here. What did we do here? No, it's just option. I think let's see. Let's read this error more closely because I think that there was something here. Yeah, can it be called on Atom? So Atom doesn't satisfy the display trait bounds. Okay, which is fine. What we can do instead is something like let's look at Rustler. Do I have that? No. Let's add the Rustler crate. I so love that Dash has gotten support for DocRS. DocsRS. Yeah, that's been a big thing for me. It saved me a lot of time. Okay, so Rustler. Let's go to the main page. So okay, so Atom, it implements debug. So we can just do that. We don't need this. We're not using it in our conversion, but if we wanted to, that would fix that. Okay, let me clear and we'll run compile again, and there's going to be a bunch of problems. Okay. So parser, we're not using that. How? Did I not? All right, let's look at that real quick. That's just a warning. Okay, so this error is ambiguous, which is probably why it's thinking that is not used. So, and it's probably that this Rustler, let's be explicit about that and see if that works. I think with Rustler, we might be accidentally importing everything. And we don't even need it here anymore, right? Because we're using plain standard results. So let's remove Rustler and see if that fixes that problem. Okay, so we got some different things here. Oh, okay, so I'm sorry. We need Rustler resource because we're doing that down here, right? Now the problem is here we need, what is the T? The T here is Tree-Sitter parser, because that's the thing we're locking over. Okay. Even though we're not locking over that in any of these methods. Okay, but here we are, right? Right. So that error needs to be passed through, right? So this is the generic that goes into the poison error. So this is the thing that we would be, except the poison error takes the guard as the type, not the contained thing inside the guard. So, okay, this is getting a little ugly. What we're going to do here is we're going to make a type alias, parser error, and that's going to be error mutex guard. And this is going to be parser error A, because we need a lifetime in here. Tree-Sitter. And this is one of the things I was a little bit concerned about that we would run into. Right? And here, yeah, okay. So let's go back to lock result. This contains the guard and the poison error. So if we look at the lock method of mutex, returns mutex guard underscore tick underscore t. So our nesting needs to match that. And let's go ahead and make a type. Let's just make these pub. There's no like problem with this. Tree error. And it'll be similar to this, but tree-sitter tree. Yeah, Zeal is a good alternative to Dash. That's a good point. If you don't have Mac. So we're going to change all this to that. And then that. And now we could even go so far as to say make a parser result and a tree result. But like honestly, this isn't too bad. Right? And that's sort of what they did here with lock result on the mutex, is that they put they buried the error type into that type alias. Okay, let's go down here and see where we're returning. Yeah, so this is going to be tree error. Now, one thing that we're going to have to do here is actually make these line up, and I don't like doing that, but the compiler is going to make us do that. I know for certain. We have to tell them that these two lifetimes are the same, right? Because right, remember we made it generic over that lifetime. So here we go. And this is kind of making a mess. And maybe we could do something else. I don't know. Now, actually, what we could do, for the case we're not actually returning a guard, we could do tick. Right? But in the case where we're at that lock method, where we're not, where it actually matters, these have to be the same. We can't just use, I don't think we can use tick underscore there. So let's go down and fix this one as well. Okay, we did. Cool. Right. And then this, we don't care about that underscore. Okay. Let's see if this compiles now. We're going to get some other interesting errors, I'm sure. Okay, so we're having some import conflicts. So we're missing a lifetime parameter. Okay. And it's saying that, use the static lifetime. Honestly, here we're gonna have to do tick A, and I think it's because we're returning the new one, but I'm wondering if it's going to complain about it on all of these things. Okay, so we need to import Rustler env. Okay, and we're gonna have some other errors to deal with. Okay, we are not using deref. We can remove that. Let's get, yeah, and there's a conflict there, so we're gonna have to fix those. Okay, we're not using deref. Let's remove that. And then in query, it's conflicting with the Rustler stuff, I guess. But we're not using, now we're using the derives, right? Yeah, so let's just use Rustler NIF struct. I don't think that, now here's the funky thing here about this error. We're probably going to have to make it generic over T, because we don't know. We don't actually care. We're not locking anything, but this is like, this is the challenge of having that poison error be buried into our error type, because it's generic over something. We also have to be generic over that thing. Okay. Yeah, we are not importing Rustler's error anymore in that file. Before we compile again, let's go down a little bit. Okay, so that, we're just talking about the conflicts again. Okay, so I think this is the problem where I didn't specify the generic on it, and so it thought it was the Rustler error rather than our error, because that was in query. We just fixed that. Okay, and so here we need to make sure that okay, what we'll do here is we'll fix that real quick. That's actually easy. So every place that we're doing unsupported language, we'll say error atom around that, and then it will auto convert for us. Let's see. Yep, let's try converting again. There's probably going to be a few other errors. More than a few. Fun. Okay, we still have ambiguity here. So I think that we need to be a little bit more careful about what we're using from Rustler. So we need NIF. We need NIF result. Right. We need resource arc. We need binary. I wish there were a import everything but. That would make a lot of things easier. Yep, NIF, 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 NIF. And there we're calling Rustler init explicitly. So let's see. Okay, we have another conflict, some more conflicts. The other thing we could do is maybe not use error star, but explicitly say where we're create error like that. And then we don't have to fight the imports. Let's revert this to Rustler star. Okay, let's find the other places that it's okay. So did I typo that? Yes, I did. I was supposed to remove the extra parens here. Right, so I was just supposed to do that. Because it's not a call expression. You know, the other thing we could do here, as opposed to this, because this is only in a few places, and it's not related to that poison error, right? We don't care about the T. Let's reconsider that. Maybe we get rid of this because this is can we format? Yeah, let's get rid of this. And I think what we'll do then is we'll make a quick let's look at that Rustler error. The thing is we want the box so that it returns error term. But we don't have a function that'll make that real quick. So why don't we say let's make a little utility function down here. Language error. Okay, and this is going to return a Rustler error. And what we want to do here is basically take this, except we're going to do and this is going to be term box new. Yeah, so like, you know, this is kind of what we were doing in the other one. And then we can just call this in all those places. Right. And I think those are the only two places. Nope, here we go. Okay. Yeah, because then we don't have to care about what that generic thing is when we're constructing it. Doesn't really matter. Okay, we still have some conflicts. Let me clear and we'll figure this out. Okay, in the error crate or in the error module, we're not using Rustler. Cool. We don't care because we're not supporting atoms anymore. Okay. Um, parser set language. Right. So this is, I think, a thing that I expected us to run into. Right. So we'll just return that because this now returns our crates error, which can be converted into, and we need to do the same here, right? Not a big deal. Because we were returning that directly. So this, maybe Isaac, you had alluded to before, map versus map error, like, and on those things and the question mark. This is why I wanted to do the question mark, and it'll make the code a lot more linear and a little bit less chain heavy. Right. So we could do this. Actually, that's kind of a nice way to put it. Okay. I love it when the compiler tells you the right way to do things. In this sense, I think the Elixir compiler has a lot to learn from the Rust compiler. But it generally has less capabilities, so it's, the types are less defined. Okay, so this is where we probably need the question mark again. So on line 90. Right. So we can do the okay question mark dance like we did up above. Getting closer. Honestly, we don't care. Maybe we could just say yeah, we have to help out the compiler here. So maybe what we could do is actually specify that on this. The thing is, I don't think it actually helps anything. We're not locking anything in here, right? So the contents of this doesn't matter. We just need to tell the compiler which one it is. Um, here. We're gonna judo it. We're gonna say error dummy. Then we don't actually care, right? But it should compile. Okay, so now we're getting the interesting stuff, right? So now it's saying lifetime may not live long enough. Yeah. And it's because we are... I think I've run into this with like ref cells and things in other code. I've done it work. This is not going to be fun. And it has to do with the fact that when you create this guard, Um, we could try this, returning it directly, and see if that fixes the problem. But I have a doubt. I think it's that. Now we can look at lock again here in the documentation. I can type. The thing is, it doesn't say what this lifetime is. So I think what's happening here is inferred to be the lifetime of the caller, and this method is not generic over that lifetime, so we can't specify. Now we could say maybe the answer here is this. I bet that might solve it. Now it should infer that, but maybe since we made it generic over that lifetime, it's not going to be. Let's try that, and let's right. Okay. Oh hey, I convinced the compiler about lifetimes. Success. Cool. Okay. So let's run the test real quick. Make sure nothing blows up. Yeah. Okay. So we did a lot more than I wanted to. But let's make a commit on this and create our own error enum with this error. And that's a very euphemistic way to put what we just did. But I beat it. I beat the lifetimes. Feels good. Okay. So, yeah, and I really hate adding lifetimes on things like that. Sometimes you just have to. So, okay. Cool. Now, there's an argument to be said that we could put tick underscore in all these places, and it would just say, hey, because this reference is passed in, all of these lifetimes have to be the same. But I don't know that that would work. This we are telling it what it needs to know. So I'm happy with that. All right, let's switch real quick. Let's look at our to-dos. So yeah, and we removed that, so we're good on that. Cool. And did I push? Okay, let's put this aside. And I have the tutorial from the Bevy game tutorial. And so let's talk a little bit about what's going on in here without going too much into the tutorial, because I do want to start on our own project. And get rid of the gum there. And yeah, so I mean, it's pretty straightforward. You create a new crate, you add the Bevy crate. They also require rand because they're spawning some entities, random positions. And then you define a main function. Now we're doing. I might structure this a little bit differently than they did in the tutorial, but basically define all the modules that you have in your crate. You import Bevy Prelude, which basically gives you everything you need. Then I'm using the explicit plugins. We'll talk about what plugins are basically in a little bit. And you create an app. You insert some built-ins. So they're saying, clear the screen with this color. Insert an ambient light resource, which lights the scene a little bit better than the default. Add the default plugins, which has like logging and stuff like that, and then all the plugins that we defined, and then run. Now I removed the debug plugin because it's noisy, and Bevy's logging is better. But if you cargo run this, we should get, yeah. So we've got a spaceship, and yeah, pretty cool, huh? So yeah, it hit my spaceship and I died. And that's basically what this does. And let's look really quickly at the just to give an example of what the plugins do. Let's look at the spaceship plugin. So we're going to have to talk a lot about the structure of the Bevy app as well as the things that you do when you build something. And then what we'll do is we'll start a new project. We'll add Bevy to it. I have an idea. I would love to hear your ideas too of what we should do. But let's look at the spaceship plugin. So the essence of what you do when building the data for a Bevy game is you define components. So entities are the like entity is the best word for it. It is the things that interact in your game, the things that exist in your game world, and they have components attached. So rather than having a like object hierarchy for your game, you have it's more like a database. Your entity is an ID, and you have and that's like a primary key in the database. And then you have sort of a star schema. You have other tables, so that are what are called components, and the entity will map to whether it has a component or not of that type. That's a simplified way to think about it. It's more like complicated in the actual storage. But so you'll often define these zero size types, like here, this is a component that says this thing is a spaceship. This is a component that says the spaceship has the shield up. This is a component that is a missile that was fired. And you always derive component debug. And then you define plugins, and plugins are also usually zero size types, unless you're trying to instantiate a plugin multiple times with different contained types. That would be kind of weird. But you take then you implement this Bevy trait plugin for that plugin, and this is where you inject entities into the game world, or you add systems, which are functions which run on particular schedules, and that's what this is doing. So this is saying we're adding a system in the post startup time that spawns a spaceship. So that's how that spaceship got put onto the screen. Is it called this spawn spaceship function after startup was done. And then we add systems on update. That's what happens every frame, basically. And these systems that we're adding are the movement controls, the weapon controls, and the shield controls. And this chain says that these should be executed in order rather than in parallel. And then the inset is kind of complicated, but it's a way to let you group your systems into your own like game specific order. So this is saying like we want to do this when we're handling user input. And then let's work real quick the spawn spaceship. This is what creates our spaceship on the screen. So note we had this type up above, which is a zero size struct as a component. And it's just spaceship. It just says this thing, we're spawning an entity. So we're creating a new primary key in our database, and we're going to associate with that primary key a spaceship. And then bundles are a way to group a bunch of components together so they can be instantiated at the same time. And this project created a moving object bundle, which contains velocity, acceleration, a collider, which defines how this thing will collide with other things, and then the model, which is another bundle. And this scene bundle comes from Bevy. So we give it the model, like the spaceship asset, basically, and we give it a translation, and then we just use the defaults for the rest. So this is the sort of thing that we'll do. Now, you may have seen earlier when I was command tabbing that here's my idea. So have you seen Survivors games? Like this one I love a lot. It's really hard. You may have also seen Vampire Survivors, and hopefully you can hear the audio on that. Let me know if you can't. So I played this game a lot. but it basically lets you pick different regions to explore. So like we could go into the grasslands, and we can, you know, pick. Let's pick this level. It's going to get us 2x gold and so forth. The main thing I wanted to focus on in this is that not necessarily like all this extra stuff around here, but the gameplay, which is essential to the, you know, the survivors genre. Let's pick the farmer. She's cool. Where you have a bunch of enemies that are coming towards you, and you have to dodge them or defeat them, right? And you collect things to make you level up, get skills. We may not do that. But the essential thing here I want to get is you can move your character around, you spawn enemies which chase you. Maybe they, you know, completely smart. But this game is so much fun. I don't want to spend my whole time playing it, but now let's get the watermelons. Those are cool. Bombs are always great, right? Oops, I got hit. So you can see there's a lot of things that we can do here. You can have you know, a component which is how many health points do you have. You can have components like what are your weapons, and then also like all these entities are the things that are in your game, even things that like despawn. Like let's say you throw a watermelon as your weapon, that thing is going to be a projectile that you have to track, and then you can despawn it. Of course, this game is very complicated. We'll start with something really simple. If that sounds good with people, let's get started. And let's go over to iTerm here. CD code. Okay, so we're gonna say cargo new, and I don't know. Let's call it Survivors game. Okay. I think the technical name of the genre is a roguelike, but yeah. Okay, so we're gonna cargo add Bevy, and then I'm gonna open this up in Zed, and okay, so we've got our main RS. Doesn't do anything. We have Bevy. One thing I need to do is we're gonna. Bevy has a lot of dependencies, and they take a long time to compile. So adding this, you know, adding op level 1 in the dev mode will mean that our app runs a little bit faster. But the big thing is we want to optimize out. Let's see here. Let me close Tree-Sitter. We want to optimize out the. Let me close Hardhat as well. The extra stuff in those dependencies, because we don't really need them. And I want to make doubly sure that that is correct, because I think I saw an error on it. But let's cargo build. Let's see, profile.dev.packages. Is it package? I bet that's it. So you see these take a while to compile. Let's actually just kill that. Yeah, now it's not complaining about that key. And we will only have to build this like fully once, and then our rebuilds will be faster. You can see, yeah, there's a lot of crates that come with this. We might look at how big our target directory is here in a second. But let's just get some basics going, sort of based on the tutorial that I showed you earlier. While that's compiling, let's switch over to main. We're going to use Bevy Prelude. And because I'm not in a NIF, it's going to be happy. So we'll say app new. And we'll say add plugins. Default plugins. And that'll give us the run. And we're going to run. That'll give us the basic stuff. It'll start up the window. It'll log things, and then it'll be all the stuff that we basically need to get started. Yeah, so you can see this takes a long time. That's not really that interesting. Let's look really quick at some of the other things that this is doing. So the asset loading is particularly interesting. We might actually copy some of these things from the example. I don't know that we'll use the GLTF stuff. We may want to do 2D, which is going to be different. We might have a sprite sheet, or we might have like individual image assets, in which case we wouldn't be doing this sort of thing. Okay, let's see where we are. Yep, we're still working on it. Okay, cool. So maybe while that's compiling, let's look at, we're going to close that. Let's look at Kenny. So if you have ever looked into, what might I do to get started with a game, a number of years ago I did a thing in Elixir that used Scenic, and I used some assets from this artist or this group of artists. All their stuff is free, Creative Commons 0. You can contribute, which is always a good thing to do. But if you just want to get some stuff to get started, they have some great stuff. I think the style is particular enough that you're going to know that it's a Kenny asset. But let's look at their 2D stuff. Maybe, so if we're doing a survivors game, we want something with some characters that are enemies and some characters that are battlers potentially, and some backgrounds. Maybe this tiny dungeon, right? That might be good. Now this is going to be really small. It can be pixely, so we might want to scale them up. Let's keep looking at what they've got going on here. There's a micro roguelike, again, like a really small sprites. Monochrome RPG. Nope. Oh wow, I can actually hear the fan on my computer. I almost never hear that. Okay, so it built. Let's actually run that real quick. Okay, so we're getting a screen. It doesn't do anything, but you can see, it's using the logging facility that Bevy has. It's printing out, what sort of graphics driver we're using. It's starting up the window, and then it's printing out, some diagnostics. But the main thing there is it started up the window, and we didn't have to do anything, which is pretty nice on that front. Okay, let's go back to our assets. Maybe we should just start with this RPG Urban pack might be interesting. Aren't that many characters in there. Looks pretty neat. I'm going to flip through here for just a few more minutes. We could do tanks, which is, I've used this pack before. I mentioned for my Elixir based game that was. All right, let's go back a couple pages, and let's use. Was it the micro roguelike? No. I forgot which one I was looking at. I think it was on the second page. My apologies. I should have downloaded this earlier so we'd be ready. Okay, message from Isaac. Doing a project with ECS is still on my to-do list. I don't know what I would build, but I've been thinking about some rule engine interact with the game world. Yeah, like I think ECS stretches your brain to. Here we go. We're gonna do tiny battle. That looks pretty cool. I want to say tiny dungeon. That's the one I was looking for. Okay, so let's download this. Let's continue without donating. I'll make a donation later. Okay, so we got this. Let's show that in Finder. And we're going to copy this over to my code directory. Go in there, please. And then we have Survivor's Game. Okay. Let's expand that. Now, Bevy expects you to have this assets directory. So what we're going to do is let's just put that in our assets directory. And then when we go to load that, now there's a tile sheet. So we could use this in packed form. I haven't used Bevy's tiling stuff. But what we probably use is just the individual files for now, and we can make the other stuff more efficient later. So we've got a little wizard dude. Gosh, that is small. We've got a generic guy, a guy with a beard. Looks like a warrior of some sort. Another generic guy. A knight. A knight with his helmet open. A knight with no helmet. Woman. Old woman. I don't know. We got a lot of stuff to work with. Hey, there's a ghost. That could be our first enemy. Those really are tiny. That might be a challenge. Well, let's see how far we can get. Main thing I wanted to try to get done today is like show something other than the black screen. So let's start just here in main. Let's make a let's actually make a new file, and we'll say let's make an asset loader, and we will do this asset loader. We'll do this like we did in the in that other tutorial, right? So every one of these has to import Bevy Prelude, and we'll make an asset loader plugin, and we'll import plugin for asset loader plugin, and then this will just do nothing for now. What we will want to do in here is similar to this. So we will create a resource. So maybe let's just do that. And it's not going to be a scene. It's probably going to be sprites. Right? Okay. Let's say sprite assets. And right now it's not going to have anything in it. But what we can do is go app init resource. And I think that takes a generic over sprite assets. Yep. And right, so we will probably want to make this system. Let's go ahead and do that. Add systems. One thing you may notice here is that, like, unlike the code that we were doing in the Tree-Sitter NIF, there's a lot of stuff that just happens automatically, and and this will just be like, it doesn't do anything for now. What we'll want to do is make sure that we know how to create these sprites. So we may have to look at the documentation of what that what the contents of a sprite is. How do you construct it? Okay, so let's go over here to main, and we're gonna have so we can start get this on new lines so I can read it. So these are the Bevy built-ins, and then we're gonna do our own. So our plugins, and I'm gonna say add plugins, asset loader plugin. Okay, so we just created our first plugin. It doesn't do much. And now see, we're starting to get some errors here. So what is that error? Let's look. Oh, add systems is the problem. Okay. You may have seen in the other example, you can add as many systems as you want at once. So let's look at this. And let's look at Bevy sprites. I think we might be able to do it in Dash. Bevy. It has not indexed it yet. I added Bevy. I think I need to... So the problem, I think the problem is, maybe I just didn't add it earlier, but Bevy's main thing is that it re-exports all the associated crates. And that's how you get that nice prelude. So we might have to go just on docs.rs right now and see about how to get these going. So right, so we're getting the default features. We don't need any of these things, I don't think. Okay, so yeah, Bevy asset probably re-exports the asset Bevy asset crate. That's what my guess would be. Let's look at what we get in the prelude. You know, we get a lot of these things exposed. Let's see about, there should be down in here sprite or sprite bundle. So there's scene bundle. So scene is what the other the tutorial was using, because it was actually using GLTF objects. But what we want is sprites. Okay, so I think the sprite here is the actual... Yeah, I don't think that's what we want. The sprite bundle, so we need a texture. Right, so when we're spawning this, we want to have... So really what we want to load is this image. Yeah. Yeah, so let's look real quick at our tiles that we have available here. Again, those are really tiny. Actually, kind of wish I'd picked something bigger. All right, let's for instance, let's load the ghost. So so ghost is going to be a handle to an image, and our load assets is going to have to be similar to the one over here. So we need we need a resource, which we take mutably, and the asset server to load the asset. Okay. So let's do mute sprite assets. It's going to be a res mute. So that means it's a mutable handle to a resource. And the asset server is going to be, I think it's just res. Yep, res asset server. Okay. And then we're going to say star sprite assets, because we're going to reassign it. Yep, so they did it like that. And we'll say ghost. It's going to be asset server.load. And all of the paths when you call load here are relative to the assets directory. So we wanted to load tile 0121. So let's start with that. 121.png. And let's look at asset. We don't need assets on there. It's Kenny _ tiny - dungeon. We'll have to clean this up later if we want to continue using this. Tiles, right? Okay. So what's going on here? Ghost is never read. Okay, so we don't have to worry about that. What we want to do is, now that we have this image loading, hopefully, let's cargo run that just to be sure. It doesn't care about that. Okay, so if we look back over here, it's not complaining about not finding that, right? So I think we're good on that. Let's make a ghost mod, and then we can start spawning a ghost. So we're gonna have to make a plugin, and we may have to do some stuff with the camera. I'm not sure yet, but let's start with something simple. And let's make a plugin. Okay, and here we'll do the input plugin dance, right? Okay, so we're going to do something that let's make a ghost, right, as our component debug. So what we want is to create an entity. Like, we're going to spawn an entity. It's going to have this ghost marker struct on it as a component, and then it'll have a sprite, and we will define where that sprite gets put on the screen, and it will come from. We're going to use create asset loader sprite assets, because we're going to need that to put the actual like sprite in there. Okay, so we're going to say app dot add systems post startup, and we're going to say spawn ghost, and then we will make our spawn ghost function. And this is the first time you'll see this. Commands, which is triggering for me. Ask me later. Not triggering in a bad way, triggering in a hilarious way. So commands is how you add or remove things from the ECS. So it is basically a queue, and it just records what you want to do. And then that executes. It's deferred until the next time that the commands can be flushed. So it's safe to just spawn a bunch of things, and then at the next tick will all of those things get added to your game world. So what do we need here? We need the sprites. What did we call it? Sprite assets. This is going to be a res of sprite assets. And I think we don't need a query because we're not trying to mutate anything. We're not trying to perform an action. We're just trying to create. Okay, so let's do command spawn. And we're gonna add a ghost. And then let's look back at the so we wanted a sprite bundle, right? So the sprite, I think this implements default. Yeah, we'll probably just do default. Rect is min max. Opposite corner is glam. Okay, so that's a glam vec2. By the way, glam is an excellent graphics math library. It's just good to know that when you see vec2, you're actually getting glam as vec2, and rect has min and max. Okay, axis aligned. I don't think we'll need to flip X or flip Y. We'll find out. If it shows up upside down or backwards, we'll turn one of those on. We're not going to tint it. Custom size. Okay, so we don't need that. And actually, that's optional. Anchor point of the sprite in the world. So that's probably... Yeah, position relative to this transform it defaults to center. So we don't really need to even change any of that. Colors default, I think. Does it implement default? Yeah, it does. So we really probably don't have to change any of that. What we do need to change is we need to add the texture, and we probably need to position it. Which we can do with transform. So transform has some constructor functions. Yeah. Okay. So let's make a sprite bundle. Sprite bundle. And this is going to have texture is going to be sprite assets dot ghost dot clone. So clone it. The handle is just a handle. It's trivially clonable. And then let's just do default here. What's wrong here? Oh, I need to make that public. That's a good point. And that's why I was complaining. Okay. So, yeah, so let's see if we can... We're going to add our system here to post startup, and it'll spawn a ghost. And so let's add that to our thing. Ghost plugin. And what I want to see, if we did this correctly, is that the window will pop open and we will see, probably tiny, a ghost sprite on the screen, in the center of the screen. If it doesn't, we'll figure some things out. We'll try to debug this thing. Okay, so we got an error here. Oh, right. So part of the problem here is I returned the results of command spawn. We don't actually need to do that. And I have too many dots there. Okay, that looks better. Okay, and I'm not seeing a ghost on the screen. So we probably need to do some things. Let's go look at what they've done in the spaceship game in the main, I think we want to do something like this to start with. And we might want to look at the camera stuff, because I think that what we need is a an orthographic camera, so we're rendering 2D, and that's probably pretty important for this. Okay, so let's do that. So we're adding a clear color and we're adding an ambient light. That, we can tweak this clear color maybe later, but it's important to have that so you can actually see what you're looking at. Let's look real quick at the cameras, because I think that might tell us what we need to know. It's related to this orthographic projection. Let's see about cameras. So camera 2D bundle is probably what we want. And I think if this implements default, we could just throw it in there. Yeah. Note it uses an orthographic projection. So why don't we do, we're going to make, just in case we need to tweak it later, let's go ahead and follow this pattern and make a new module that contains this same functionality, or not the same functionality, but like the same pattern where we define a plugin. And then this, as our game grows, we can tweak individual aspects without having to go through one ginormous file. And this is not working because I haven't defined it up here. Okay. And implement missing members. Okay. So here what we're going to do is we're going to say app dot we need to spawn this bundle, so we're going to add systems to startup. We're going to say spawn camera, and let's make spawn camera, and that's going to take command. So similar to what we did before with spawning the ghost, we want to spawn the camera bundle. Camera 2D bundle, new with far. I'm trying to remember what the handedness. Camera is placed at far c equals far minus 0.1, looking toward the world origin 0, 0, 0. Well, let's look at what the implementation of default is for this. Oh, it doesn't have view source. Why not, Bevy? Or is it? No, it's not off to the right. Okay. Core TD. Let's go look in the repo. I think that's the only way we're gonna find core pipeline. Core 2D, camera 2D. This is where we're gonna find where it implements default. Okay, so it uses far is 1,000 and near is negative 1,000 on its projection. Yeah, let's just use the default. See what happens. Sounds good to me, right? Go back to the docs, please. Okay. Let's say default. And we have to add our camera plugin here. And let's see what we got. Okay, we showed a ghost on screen. Cool. So, and we've got this kind of like, I don't know if you can, how well you can see it on the stream, this kind of purpley background. Let's do something interesting with this. Let's start to make this ghost move around on the screen, right? Just like we've done before, we're going to make a new module. Yeah, spooky. Let's make a module called movement. And this, similar to the spaceship game, is going to give us the systems that update something that moves on every tick. Okay. We're gonna make another plugin, right? You can hopefully sense a pattern at this point. And let's go ahead and add this mod to our movement. Okay. So I think what's neat about this so far is that you can tell I haven't written that much code, and I already have something displaying on the screen. Which, like, if I had to write this code myself, like all of those guts of, hey, let's display something in 2D and use a sprite, and like, I think I would lose my mind. So this is why, it can be nice to use a game engine like Bevy. Okay, so I don't know. Oh yeah, so we're gonna add systems here, and what we want is, when we spawn the ghost, we want to give it, we're going to define a bundle here. So first of all, let's derive bundle. It probably needs debug. I forget. We'll look at the other one in a minute. Movement bundle. And this is going to have some stuff in it that will, and we can derive default, I think. This is going to have some stuff in it that tells us how to transform a moving object on every tick, on every update. So we're going to add systems to on the update phase, and it's going to move objects. That's probably not the right name for it, but we'll start with that. So we need to have something that represents the velocity, and that's going to be a vec2, right? So this will be a description of how this moves on every frame. Okay, so let's say pub velocity is going to be a velocity. And when you instantiate one of these bundles, or you use the default, in which what we'll probably do to get this kick-started is use the default on Ghost, which for the default for vec2 is 0, like 0, 0. Let's use create movement bundle, and then we'll say movement bundle default for now. And then when we go to spawn this later, maybe we can use the rand crate and pick a random direction and speed. Okay. So yeah, that's the other thing that we could have represented velocity as. We could have a normalized vector and a speed, so direction and magnitude. But we can keep the speed in there, and if we need to change the speed, we can normalize the vector and then multiply by the speed that we want. So okay, so let's add systems move objects. So let's make our move objects. This is going to be the first interesting one that we do when we're doing something on every tick. So what we want to do is get we want a query. I think it's mute query. So we need query mute. And this is where it gets interesting. These types that Bevy provides. What it will do is look at this type. And this type will define a specification for a kind of entity that's in your system. Or in your game world, rather. And what we want is we want something that has a velocity. And what we want to get is a transform. I think that's the correct way to do it. Let's look real quick at the spaceship game and look at their system. So they have update velocity acceleration. So yeah, so it's you make a tuple of the thing that you don't want to change. So here we're not changing the velocity, but we are changing the transform, and we'll use the time as well. And what does their velocity look like? Yeah, it just says velocity. They're in 3D. So okay. So yep. Okay, so the essence of the query is that you always iterate over it. So you'll say velocity for velocity mute transform in query. Now what we want to do is transform dot translation, and we actually need the time here, and that was res time, I think. Yep. So because your frame rate may not be the same as your game time, they gave you the clock and an idea of how much time was elapsed since the last time it drew, or the last time it evaluated your game logic. And this lets you, get consistent speed. Because like if we just said, plus equals velocity dot 0. Let's see, it's a vec2. Do I have a glam in here? Glam. I do. Vec2. I think there was extend. Yeah, we can do extend. Probably might be better, even though we're in 2D, to have this be 3D, because that's what the coordinate space of the world is. So let's just say velocity not 0. Now, if we did this, if you had inconsistent frame rates, you would get inconsistent speed. So what they do here is time elapsed seconds, I think is what they did in the other one, or delta seconds. Yeah. So you say delta seconds, and then that means that our velocity can be in, say, like meters per second, and you multiply that by the delta seconds, and that gives you the offset, the translation. Okay. So I think we can, let's add plugins. Movement plugin. Look at our code here first. Okay, so velocity needs to implement debug and default, and then we can, we get a 0 velocity. Okay, so one thing we might do here is it just query? Yeah. And we need, I forgot, we need iter mute. I believe that's correct. Yep. Okay, they used to, I think in older versions of Bevy, they had query and query mute. You just need query now. And then you either take a mutable iterator or you take an immutable iterator. Okay, so we basically did the same thing as what they did. And we didn't crib on it too much. That's good. So let's run this. What should happen is our ghost should display and not move. Right? Spooky. Okay, so now let's give the ghost some movement. So instead of default, let's fill out the struct fields. And we're going to have to import velocity as well from there. And let's see, vec3. Do we have the vec3 function? Yeah. Let's do it like this. So let's say we want it to move up and to the right. So it's going to move in the X, 1, Y1, and 0 in the Z. And let's see if we can get it to move across the screen. What's wrong there? That needs to be public. So let's go ahead and make this velocity new, and let's give X f32, Y f32, and that's going to return self. And then we'll say self vec3 new X Y 0. And that's actually probably good that I didn't make that public. Because that forced me to think about what the interface is. So we can say velocity, since we're operating in 2D, then we can hide the fact that we don't have, we don't care about that Z dimension. And is that pub? It is not pub. Now it's pub. Okay. And let's see what happens. It doesn't move. Okay, so what we should do then, let's look at our movement. So we add systems, update, move objects. Let's print now. This is going to print a bunch of gunk to our console here. Maybe we don't want that, but for now, let's see. Because what I want to see is it actually running that system? Yeah, it is. So okay. Let's include the entity here, and see. There should only be one, right? And that probably has debug. Oops. Okay. The interesting thing there might be related to sprites, but I don't know yet. So it's moving this, 2v0 is our ghost, and the reason why that's our ghost, so that's entity 2 version 0 of it, is that the camera was the first thing we spawn, right? So the camera spawns at startup. It spawns this camera 2D bundle. but our ghost was spawned later. Yeah. Let's look at, so this is update position. Let's see. So this movement plugin, it calls update velocity and update position on update. Let's rename this to update position. Update position. Now the other, this is about scheduling, like controlling the order of these things. We're not worried about that yet. So we should see that running this, because we basically have the exact same function, except we use velocity 0. Let's do that transform. Yikes. I don't want to generate delegate impulse. Maybe it's on this. Yeah, convert to name struct, and then we'll rename that. Rename that symbol to value. Okay. So there we're basically doing what they did in the other one. I don't know that helps anything, but we then have the same exact code except for this entity. Maybe what we could do is let's do with ghost. Only move the ghost. Not that that'll matter, but okay. Yeah, that's not making a difference. Let's look at the make sure it's actually changing that. No. I'm kind of running out of ideas here. If any of you have ideas, I would love to hear them. Otherwise, we might call it for the day, and we can debug moving this ghost around. The other possibility is that I'm not correctly understanding sprite sheets, so let's look real quick at the Bevy docs again. And in the prelude, not sprite sheets, but sprite bundles, because there might be a possibility that there's something. Yeah, see, this injects a transform. And I don't think that we changed the global transform, but we could try that. See if that changes anything. The thing is, the global transform is usually computed. Yeah, so to place or move an entity, you should set its transform. Right. To be displayed, entity must have a transform and a global transform. Okay. Transform is the position of an entity relative to its parent position or the reference frame if it doesn't have a parent. So our ghost doesn't have a parent. So it should be relative to the reference frame. This system runs during post update. So you run your transform modifications in update, and then in post update, it applies them. Okay. Let's look at their examples. Okay, so Okay, so they have a setup function. Yeah, so they're creating a sphere, an icosphere, and adding materials to it. Transform. Okay, so they're doing a transform from translation vector 0, which is the default. Interestingly enough. Okay, and so they're adding this bundle, which is a 3D bundle. To be clear, PBR means physical based rendering, so that's like describing the kind of shader that it's going to use. That's what the PBR means there. And then it's setting the center, so this is the scale factor stuff. And then it spawns a cube, also with a PBR bundle, and it makes a cube shape. And spawn. Okay. So they spawn a 3D camera bundle looking at 0 with Y being the vertical. Okay. And a point light. So, right. So they're doing something really similar here. So they mutate the transform, given the cube state. I wonder if this is not up to date. And we could try this and mute cubes, a similar thing in our own code. Okay, move the cube forward smoothly at a given move speed. So interesting. Maybe we need to do something like this. No. We just want to modify the translation. They're doing something similar here. Let's try, rather than itermute here, let's try mute like that. I don't know if that's going to work or if even it's going to compile. Okay, our ghost still doesn't move. That's disconcerting. Okay. Right, so I think let's switch over to the one that works and see what we can learn here, if anything. Okay, so in main, they had the movement plugin after the other stuff. Not that that matters. Yeah. Okay. Let's look at their movement module again. Okay. So velocity acceleration, moving object bundle has a velocity and acceleration and a collider. We'll probably make a really simple collision, which is based on the size of the texture, which is fixed. Pretty simple there. We don't have to worry about colliding right now though. And then they have the scene bundle, and we might do something like put the sprite bundle down in there. Okay, and then their systems are just update velocity, update position. Yeah. This is an unfortunate place to leave this, but I think it's time to quit for the day. Thank you all for coming today, and I'll stick around here for a minute or two. We can drop stuff in the chat if you have ideas or questions. I'm glad we got something to display. I actually thought I was going to be able to make it move, which is unfortunate that it didn't work. So yeah, beware. There are some really good tutorials out there. The one I showed from I always forget his name because it's kind of weird. Zymanter Games or Zymartu Games, yeah. And Chris Biscardi's Rust Adventure has some Bevy content as well. Definitely recommend you look that up. Yeah, did you already solve some AOC puzzles off stream? No, I actually decided that it's gotten too far in and there are too many solutions out there already. I did not want to do them on stream, and I'm not going to do them off stream this year. I think I'm going to skip. Which, I learned a lot by doing them in Rust last year. They can be fun. They can also be really frustrating, and consume a lot of time. So partly because they sometimes have little tricks. If you don't notice the thing in the word problem, or you're not familiar with that particular kind of problem and that trick. I think there were some of the days last year I got up to like 15 or 16 before quitting. But the some of them took days, multiple days for me to finish, which was frustrating. And it was really about like, can you translate the word problem and guess the subtext as well as what the author of the problem was thinking. I Sometimes that just feels too gotcha. It's like having a leak code interview or something for a job. You're like, yeah, are you actually testing my skill, or are you just trying to trick me? You make me implement Euler's algorithm on the whiteboard. No thanks. Sometimes they feel like that. But anyway, hopefully next time we'll be able to continue with this. I think if we can get the movement to work, Bevy is really cool. Yes, the valve problem from the previous year. That's a good point, Isaac. I think I actually blew up my machine trying to solve the valve problem. Ran out of memory or something. It was a bit much. Anyway, have a wonderful Sunday. Thank you for joining me, and continue to interact. And we'll hopefully have some more fun with Bevy next week. Take care.